In this video, I want to find the limit as x approaches 0 of 1/5 times 3x minus sine 3x over x to the fourth. So let's first factor out the 1/5. And if I plug in x equals 0, I get 0 over 0. So I'm going to use L'Hopital's rule. The derivative of the top is 3 minus 3 cosine 3x, and the derivative of the bottom is 4x cubed. Now I can plug in x equals 0 and get 0 over 0, but I'm just going to clean things up a bit. And I'm going to factor out a negative 3 from the top. So we have cosine 3x minus 1, and then over 4x cubed. So I have a negative 3 factor and then 4 on the bottom. So that comes outside, multiplies it by 1/5, and I get negative 3 over 20. And I can still plug in x equals 0 and get 0 over 0. So I have to apply L'Hopital's rule again to get negative 3 sine 3x over 3x squared. And then the 3's are going to cancel from the top and the bottom, and then the negative is going to cancel with the outside. So I have 3 over 20, limit as x approaches 0, sine 3x over x squared. If I plug in x equals 0, I still get 0 over 0. So I use L'Hopital's rule. That gives me 3 cosine 3x over 2x. And I can factor out the 3 halves. And I multiply that by 3 over 20 to get 9 over 40. And at this point, if I plug in x equals 0, I get 1 over 0, which is undefined. But the way I'm going to do this is break it up into two separate limits. We know that cosine 3x approaches 1 as x approaches 0. And so we're just left with limit x as x approaches 0 of 1 over x, and then on the outside is 9 over 40. But notice 1 over x looks something like this. So as x approaches 0 from the right, clearly that goes to positive infinity. And as x approaches 0 from the left, it's equal to negative infinity. So because the two limits are not the same, we say that the limit does not exist.